So welcome to section 9.2, Understanding Interest. The objectives in this lesson are to calculate simple interest, understand future value, calculate compound interest, and to calculate annual interest percentage yield. We have some terminology in this section. First is interest. This is the amount charged by a lender for borrowing money. Second is the principal. This is the sum of money on which interest will be charged. Our third term is interest rate. This is the amount charged to the borrower expressed as a percentage of the principal. The next phrase, annual percentage rate, is the yearly interest rate that is charged for borrowing. APR is normally given as a percentage per year. And the amount of interest on a simple interest loan with principal P, an annual interest rate R expressed as a decimal, and a loan term of T, usually expressed in years, is calculated with the following formula: I equals P times R times T. Again, this would find only the interest on a simple interest loan. So example 1 says calculate the simple interest. So we want to determine the simple interest that is accrued on $5,500 for 5 years at a rate of 8.5%. So we want to identify our P, our R. So we took the 8.5% and expressed it as a decimal, and the T, which is 5 years. We recall our formula. I is equal to P times R times T. So I is equal to 5,500 times 0.085 times 5 years. And we get $2,337.50. That is the interest charged. If the original principal has not changed, then there would be a debt of $5,500 plus $2,337.50. And we would call this the future value because it is the principal plus the interest charged. So the future value of the loan would be $7,837.50. That is the principal plus the interest. In example 2, purchases with simple interest. It says Ian is purchasing a new television with a deal from the Big Screens R Us television store. The deal offers 90 days, same as cash, to make the purchase. This means that at the end of 90 days, if Ian has paid off the cost of the television, he owes no interest charge. However, if Ian does not pay off the amount, he owes simple interest for the original purchased amount calculated over the entire 90 days. If the price of the television is $2,650, and that is with sales tax included, and there is an annual interest rate of 21.99%, how much would Ian owe on the 91st day if he made no payments during the first 90 days? So we want to recall the simple interest formula. And from the problem, we have the principal of $2,650, the interest rate of 21.99%, and the time of 90 days. Our goal here is to find I right now. So I is equal to 2,650 times, we want to change 21.99% to a decimal. And we need to convert 90 days to a term of years. So 90 over 365 gives us 0.247 of a year. So we see that the interest is $143.94. If we go back to the question, it says, how much would Ian owe on the 91st day? And that is if he made no payments. So we have to add the original $2,650 to the interest, for a grand total of $2,793.94. This is the future value of the loan. So that means even though he borrowed $2,650 from the store today, on the 91st day he owes $2,793.94, because all of the interest was added up. And this is a common scenario in stores. Often they'll say if you pay it off in 90 days, there'll be no interest. But once that 91st day comes, they add on all the back interest. Okay, so we have a skill check. Find the total cost of a loan that is $4,320 that has simple interest rate of 15% for 18 months. So our principal is $4,320. Our rate as a decimal is 0.15, and our time in terms of years is 1.5 years. To get that, you would simply do 18 months divided by 12, and you would get 1.5 years. So our simple interest is $4,320 times the 15% times the 1.5 years, and that gives us a simple interest of $972. But it says find the total cost of a loan. So we found the interest part. So now the future value of the loan is $5,292. Compound interest is the interest that is computed based on both the principal and the accrued interest, earning interest basically. So the accrued interest for each term would become part of the principal, and then that would earn interest. And then that would become part of the principal, and that would earn interest. The formula for the future value is A. A stands for amount, and you can change that with FV for future value if you like, is equal to the principal. So we've been using P, that's the same. But in parentheses, we have 1 plus the rate over N, where N is equal to the number of compounds per year. And then we have N times T in the exponent. That's the number of compounds times the number of years. Here we have a chart so that as you're reading problems, if they say that the loan is compounded annually or semi-annually or quarterly, we have the values for N for each case. So if it was compounded annually, N is 1. If it's compounded semi-annually, the compounding N value is 2. quarterly n is 4, and so on. Example 3, computing compound interest. Lily deposits $12,000 into an account with an annual interest rate of 4.5% that is compounded monthly. If she leaves the money in the account for 10 years, what will be the future value of this investment at the end of that time period? So we can say amount is equal to $12,000, the principal, times 1 plus the interest rate as a decimal, divided by the number of times it is compounded. Monthly tells us to divide by 12, close the parenthesis, and in the exponent we have the compoundings 12 times the number of years 10. So we have 12,000 times 1 plus, I'm going to simplify this, 0.045 divided by 12. So this is 0.0375 raised to the 120. So it equals 12,000 times 1 plus 0.00 is 1.00375 raised to the 120. We will type this into our calculator. I did this in stages to avoid having multiple sets of parentheses and fractions, because the biggest reason for error is the way it is entered into a calculator. So start from the inside parenthesis and work your way out, simplifying numbers. And now this will become an easier number to enter. 12,000 times 1.00375 raised to the 120 power. And we see that the future value is 18,803 and 91 cents. So from this, if we were asked how much interest was earned, you would subtract the principal from it. And you would say that $6,803.91 is the interest. So you take the future value, you subtract the principal, and you found the interest over the term of the loan or the investment. Example 4, comparing results. Thomas uses $4,500 to open an IRA, and that IRA earns 3.8% annual percentage rate. If he leaves his money alone, what is the future value after 8 years? And they want us to consider the following compound intervals: compounded yearly, quarterly, and weekly. So the future value of $4,500 times 1 plus 0.038 compounded yearly, that's a 1, raised to the 1 times 8. We have 4,500 times 1.038 raised to the 8. This was easy to simplify because it was over 1. We go to our calculator, 4,500 times 1.038. Enter. Oh, I forgot my exponent. 4,500 times parentheses 1.038 raised to the 8th power. And we get 6064.45. So compounded annually, the $4,500 will become $6,064.45 after 8 years. Let's see what happens when we increase that compounding to quarterly. The future value A is equal to 4,500 times 1 plus 0.038 over quarterly means 4 times per year. We put that 4 in the exponent multiplied by the number of years. So I want to figure out what this decimal is here. 0.038 divided by 4 gives me 0.0095, and then we add 1 to it. and that is what is inside the parentheses, 1.0095 raised to the 32 power. So we have 4,500 parentheses 1.0095 raised to the 32 power, and we get $6,089.97. So we see that by increasing the number of compoundings, we made an extra $25 over 8 years' time. Let's compound it weekly. A equal to $4,500 times 1 plus 0.038 divided by 52 compounds per year. The exponent is 52 times 8. So we're going to do 0.038 divided by 52. We'll hit enter so it calculates it, and then we'll add 1, and that will tell us what is in this parenthesis. 0.038 divided by 52, and that is our decimal. We're going to say plus 1, and it gives us 1.00073. And then 52 times 8 is our new exponent. So that's 416. So we enter all of this in to get the future value. And we get $6,096.08. And if we compare that to the last one, we see we made an extra $7 almost, $6-7 over 8 years. If we compare this to the first one, we made an extra $32 over 8 years. The other type of compound interest we have is what's called continuous compounding. That means imagine that your interest was earning interest during every second of every day of every week. And the formula for this is A equals P times e to the RT power. E is known as the natural exponential base. So on our calculator, we have E. I'm going to say e to the first power, and the decimal version of E is 2.71828. E is an irrational number like pi, and it was discovered by a family of bankers / mathematicians known as the Bernoullis. You can read about the history of E and see how it was banking and compound interest that came up with the value for E. So number 5 says find the future value of $8,900 invested at a rate of 2%, 2.05%, that is compounded continuously for 15 years. So because it says continuously, that means we need to recall this formula for the future value. And we would say that the future amount is $8,900 times E. E is the constant that is in our calculator that we're going to use. R, 2.05%, we need to express that as a decimal. 0.0205 times 15, all of that is in the exponent of E. And now we can go to our calculator, 8,900 times, and we find the E in our calculator. And now in the exponent, I'm going to type 0.0205. times 15 and hit enter, and it gives us $12,104.19. Now, just as a demonstration, you would think that if it was earning interest every second of every day of every moment continuously, that it would be paying a lot more. But let's compare this to the same loan done weekly. Amount equals 8,900 times 1 plus the interest rate is 0.0205. And if we did this weekly, that's 52 weeks in the year. Raise that to 52 times the number of years is 15. And let's see how the two amounts differ. So I simplified the decimal. I'm going to add 1 to it. And now I'm going to say 8,900 times parentheses. I'm going to just copy and paste this value into here and raise it to an exponent of 52 times 15. And it gives me an answer of $12,103.45. N equals 52. So we see the difference here is less than $1 difference over 15 years. So that's one of the benefits of using this formula. P times e to the RT is a simpler formula to use. It is a simpler formula to enter, and it does not result in much difference in the payment. So for some time, banks were preferring this moment because of the errors that tellers were making using this more complicated formula. This simplified it and reduced the amount of errors and the amount of money the banks were losing because of miscalculations. Okay, annual percentage yield is the effective annual interest rate earned in a given year that accounts for the effects of compounding. So basically what it's saying is if we take the calculation of how your interest is computed, compound interest, continuously compounded interest, whatever compounding we're using, we can convert it to an APY, which is basically saying the amount of interest you would have to charge in simple interest for 1 year. That would be the same result as compounded interest for 1 year. So APY is basically the simple interest equivalent. For a given compounded interest. So in example 6, we're asked to find Samantha deposits $5,000 in an account paying 5% interest per year. It says find the APY, the annual percentage yield, if the interest is compounded monthly. So we're going to take 1 plus the rate over n raised to the n. Notice there's no t because t is equal to 1. We're really multiplying it by 1 because we're doing a comparison on a year, a 1 year interval, the annual 1 year. So that's why we don't need the t here. So it's 1 plus r over n raised to the n, and then minus 1 is to get rid of that 1 after the interest has been applied to it. And we multiply it by 100% to change it from a decimal to a percent. So we have APY is equal to 1 plus the interest is 5%, n is 12 raised to the 12, and then we'll subtract 1, and then we will multiply by 100. 0.05 divided by 12. So that is our decimal. We're going to add 1 to it. That is what is inside the parentheses. Now we are going to raise it to the power of 12, and then we subtract 1, and times by 100, and we get 5.12%. So charging 5% interest compounded monthly is the same as charging 5.12% simple interest. Let's do this again. Part B, find the APY if the interest is compounded daily. .05 divided by 365 gives us this decimal. We add 1 to it, and then we raise this result to an exponent of 365. We subtract 1, and then we multiply by 100 to express it as a percent. And we can say that this answer is 5.13%. So compounding 5% daily is the same as simple interest of 5.13%. Example 7, suppose your bank advertises the following personal loan rates. If the loan amount is less than $20,000, then the rate is 10.49%. If it's between $20,000 and $99,000, it is 9.99%. If it is greater than or equal to $100,000, 7.50%. These are APRs. Down below, we see that interest rates are compounded quarterly. Find the APY for each loan. So we'll just find the first one. The APY is equal to 1 plus, we change 10.49 to a decimal, 0.1049. It's being compounded quarterly, so it's divided by 4. Raise it to the 4th, subtract the 1 out of there, and multiply by 100 to turn it into a percent. 0.1049 divided by 4 because it's quarterly. Add 1 to it. Raise it to the 4th power because it's quarterly. Subtract 1 from it. And multiply by 100 to express it as a percent. And we get 10.91%. So that means that 10.49% quarterly is the same as a simple interest rate of 10.91%. Example 8, calculate interest on payday loans. Assume you wish to borrow $300 for 2 weeks in the form of a payday loan, and the amount of interest you must pay is described in dollars, $25 for every $100 that you borrow for those 2 weeks. This means that at the end of the 2 weeks, you would have to pay back $375. What is the annual percentage rate on this loan? So we would say 375 minus 300 is equal to $75. That's what you paid. You paid $75 for 2 weeks. Well, how many weeks are there in a year? So that's for 2 weeks, which means that how much money would go to 52 weeks? So we can use a proportion here. 75 over 2 is equal to x over 52. And when we solve this for x, we'll cross multiply. 52 times 75 is equal to 2x. Divide both sides by 2. And we want to plug this into our calculator. 52 times 75 divided by 2 gives us $1,950. So what this is basically saying is if it wasn't a 2-week loan, if it was a 1-year loan, that would be the amount of interest you would pay on that $300. Well, what percent is that $1,950 of the 300? So 1,950 over 300 is equal to x over 100. This is our percent formula from earlier in the chapters. is over of equals percent over 100. And we can solve this for x. $1,950 times 100 divided by 300 gives us 650%. And that is why these types of loan structures are bad. When you're told that you must pay a flat dollar amount based on the amount you borrowed for a short term, when you figure it out as an annual percentage rate, you're paying extraordinary interest rates. It's just undetected from the short-term pay to many people. And that is why many states have now made this type of loan structure illegal. Okay, so that's the end of section 9.2. Watch it, pause it, take notes, complete the assignments. Let me know if you have questions.